Welcome back everyone, Patrick here, and in this video what we got to do is we got to take this, we got to simplify it, and also state the restrictions. So like usual, when we get questions like this, first thing we want to do is we want to factor all the expressions as much as possible. So what I'm going to do is I'm actually going to start with this numerator here. So we got negative 6x squared plus 28x minus 30. I'm going to factor this. Now notice we could take out a negative 2 from everything, and I'm taking out a negative 2 to make that leading coefficient positive. So we would end up with 3x squared minus 14x plus 15. Right? Divide everything by negative 2. That's how we got these terms here. And then the 3x squared minus 14x plus 15. This can factor, because notice 3 times 15 is what? It's 45. And then the b value is negative 14. So what two numbers multiplied at positive 45 add up to negative 14? Negative 9, negative 5. So we end up with 3x squared minus 9x minus 5x plus 15, like that. And from here, we could take out a 3x, take out a negative 5. And then we can factor out an x minus 3. And then we got a 3x minus 5 like that. So this bracket factors into those two brackets. So we'd end up with x minus 3 times 3x minus 5. So this numerator here, I'm going to rewrite this. Actually, let's just rewrite it up here. That numerator is going to factor into that right there. Notice the 9x squared minus 25, that's a difference of squares. That's going to factor to 3x minus 5 times 3x plus 5. And then this second expression, notice that we're dividing. So what we're going to have to end up doing is flipping this expression and then multiplying it. But before we do that, let's factor what we can. Notice here we could take out a negative 3. So we'd end up with 3x plus 5, like that. Yeah, so this would be negative 3 and then 3x plus 5. Now, this one is a little bit weird. Notice we got 9 minus 3x squared, which is factored, but not fully, because notice that we can actually take out a 3 from the bracket. So this one's a little bit of a unique case. Notice how inside this bracket I could take out a 3. And if I take out a 3 from these, this would end up being what? 3 minus x. And all of that would be squared. So I just took that inside bracket. This is like a square bracket if we line them up with this. Right? This square bracket are the exact same thing. And then from here, these two are multiplying, so we could have 3 squared, 3 minus x squared. So this would be 9. And then, sorry, not 3x, what am I writing here? 3 minus x squared, like that. So this and this are the exact same thing. So this is nicer because that bracket, that factor, is fully factored as well. So I'm going to take this and rewrite it as this, like that. All right, and now everything is factored. So what we can do from here, actually, before we simplify, let's get our restrictions. So notice that this denominator can't be 0. So notice that 3x minus 5 can't be 0, which means x cannot equal positive 5 over 3. And then notice that 3x plus 5 can't be 0. So x can't be negative 5 over 3. And since we're dividing, notice that we got to get the restriction from the numerator as well here. So 3 minus x cannot be 0, which means x can't be 3. So there's 3 restrictions in this case. So x can't be positive, positive negative 5 over 3 plus minus 5 over 3, and then x can't also equal positive 3. Right? The numerator can't be 0 because then we'd be dividing by 0 there. Right? So those are the restrictions. And then notice this factor, it was the same as this factor, so we already got the restriction over there. And so from here, we can now simplify this. So what I'm going to do is I'm going to rewrite this expression here. But then this expression I'm going to flip. So we'll have negative 3 up top, 3x plus 5. And then we'll have 9, and then we'll have 3 minus x squared, like that. And then from here, notice a bunch of things will cancel out. So this and this would cancel out. This and this would cancel out. Now, notice we have an x minus 3 and a 3 minus x squared. And 3 minus x squared, that's actually the exact same thing as x minus 3 squared because of this square here. So another unique case, just this factor that was here is unique to deal with just in general. So this question's pretty good here. What we would do to show that this, and this are the exact same thing. Right? So if we plug in like 10 here, notice 3 minus 10 is going to give us negative 7, but then negative 7 squared is going to give us 49. 10 minus 3 would give us positive 7. 7 squared would give us 49. So that square makes these both the same. And the reason why, if we take this and we take out a negative 1, factor out a negative 1, we would end up with negative 3 plus x, or x minus 3. Right? If I factor out a negative 1 from this expression, but that negative 1 is still going to be within that bracket. And then these are multiplying, so we could take negative 1 to the power 2 and then x minus 3 to the power 2. Negative 1 to the power 2 is positive 1, so we end up just having x minus 3 to the power of 2. All right, so this and this are the exact same thing. Now, if this was an odd bracket or an odd exponent, then they wouldn't be the same. This has to be an even exponent here for these to be the same, because this negative 1 to an even exponent would give us positive 1. All right, so this ends up being x minus 3 to the power of 2, and then notice this and one of these cancel out. So what are we left with? Well, we'll have negative 2 times negative 3, which is positive 6, and then we'll have 9 times x minus 3. And then notice that 6 over 9, that simplifies to 2 over 3. And then we got the x minus 3. Or you might even see this shown as 3x, 2 over 3x minus 9. So both of these are the exact same thing. So these are the simplified expressions for that original expression we had. And then those are the restrictions.